Let's start with question number 25. Now the question you see belongs to section of wave optics. As per the question, in YDS experiment, as per the shown figure, what should be the slit separation small d in terms of lambda such that the first minimum occurs here directly in the front of slit S1. Let's start with the solution. We are all well aware that in order to find the minima, the path difference, that is, in order to find the first minima, the path difference should be equal to lambda by 2. Now, if you want to find the path difference, so which are the paths we are going to consider is, one is this path, the light will be coming from here, and one is coming directly. Now, if you talk about this distance, it would be d square and this is 2d square, so it would be 5d square, right? And this distance would be 2d. Now, in order to calculate it, I just have to subtract this distance from this distance, I will get the path difference. So, delta x would be equal to d root 5 minus 2d, and that should be equal to lambda by 2. Let's take d as common, you will get root 5 minus 2, that should be equal to lambda by 2. So, d would be equal to lambda by 2 into root 5 minus 2. Let's see which is the best suited option here. Among the 4 options given, option number 1 is the right answer to this question. Hope you have understood this one very well. Let's move ahead for our next question. Now the question you see belongs to a section of mechanics or kinematics. Now the particle starts from the origin and this is the graph or VT graph given for the particle. What we have to find is what is the position of the particle at 5 seconds. So which point I want you to focus is this point, right? Now here you see that the area covered will be this, we are going to focus upon. So when you find this area, this is basically from here to here is a trapezium. So this point, this and this will form a trapezium. And what is the area of this trapezium? It's very easy. Start with the solution. X would be the area covered or area under the graph. So you will get x is equals to half into sum of the parallel sides, which is the sum. So from 2 to 5, that is 3, and this is 5. So 3 plus 5 into 2 plus the area which is here in this small box. So it would be 1. So this is 1. On solving this, you will get 8 plus 1, that would be equal to 9. Let's see which is the right answer. So among the given options, option number 1 is the right answer to this question, right? Let's move ahead and see question number 27. Now in this question you see belongs to a section of mechanics chapter gravitation. Here there are 2 stars of masses 3 × 10 to the power 31 kg each, and a distance between them is 2 × 10 to the power 11 meters. Now they rotate in a common plane around the center of mass as O. A meteorite passes through O, moving perpendicular to a star's rotation plane. In order to escape from the gravitational field of this double star, the minimum speed of the meteorite should have at O is. Let's see the diagram first. So this, let's consider this as O, this being the radius R, which would be simply 10 to the power 11 meters. Why? Because the distance between the 2 stars is given as 2 × 10 to the power 11 meters, and the mass of these 2 stars would be m, which is given as 3 × 10 to the power 31 kg, right? Now if any meteorite is here, it will have some potential energy, and that potential energy, it has to acquire some kinetic energy so that it can escape out, and in order to escape, the total energy of this meteorite at this point should be 0. So let's calculate the potential energy of this meteorite. That would be minus g small m into mass of meteorite divided by r into 2, right? So let's calculate the value. It is 6.67 into 10 to the power minus 11, the negative sign should be here, into the mass of the body, that is 3 into 10 to the power 31 into mass of meteorite into 2, right? And this should be divided by r, that is equals to 10 to the power 11 meters. So this is the value of U, and when you calculate it, you will get U as minus 40.02 into 10 to power 9 m. This is the energy or the potential energy here. Now, in order to escape the total energy of this meteorite, that is U plus K kinetic energy, should be 0. From here you will say K would be equal to minus of U, that would be equal to 40.02 into 10 to power 9 m. And for kinetic energy, you can write half into mass of meteorite into V square, and that would be equal to 40.02 into 10 to power 9 m. Solving this, V will be equal to 28 into 10 to power 4 meter per second. Let's see which is the best suited option here. So among the given options, answer 1 is the correct answer. Right? Let's move ahead and see our next question.